Characteristics of good building stone includes crushing strength, appearance, durability, facility of dressing, fracture, hardness, percentage wear, resistance to fire, seasoning, specific gravity, texture, toughness index, water absorption, and weathering. We will discuss each one of the thing in the next slide. Okay, in detail we'll discuss. First one is crushing strength. We are discussing the characteristics of good building stone. Okay, what is a crushing strength? Some way or other ways, it is known as compressive strength. It is known as compressive strength. Okay, so for a good structural stone, the crushing strength should be greater than 100 Newton per mm square. You will be having a doubt how the crushing strength of a stone will be conducted. It can be conducted by taking a stone specimen of size 40 mm length, 40 mm breadth and 40 mm height. Take a stone specimen of this required height. Then apply a compression by using compressive testing machine. That compressing testing machine will be there in our strength of material lab. If you are applying some pressure, that is 0, 1, like that, the reading will show. Okay, it will show some reading. At some point, the material is crushed or broken. Just note the load. That's it. There will be a machine. It will be studied later. All those things. Okay, how in your lab you may be doing this, the experiment, by using brick. Okay, so just compress it. The crushing failure takes place. Just just note down the load. Then divide the area where load is applied. So load by area, you will be getting the compressive strength or crushing strength. Okay. Then one point you have to notice that while you are doing the testing of that specimen, it should have dipped in water for 72 hours. Okay. 72 hours you have to dip it in water. Then only the test can be conducted. That is very 72 hours is very important. You no need to study all those testing procedures. You have only the write down the characteristics of good building stone. So it should be greater than 100 Newton per mm square. For different rocks, the values are tabulated here. For igneous rocks like basalt, it will be having 185 Newton per mm square, 150 to 185 Newton. It is a very high crushing strength. So basalt is very hard. From this table, you can conclude what are the highly compressive strength materials. Okay, you have to memorize all those things. There may be questions from this also. Okay, so next characteristic is appearance. Whatever, if you are analyzing you or me, your first impression is the best impression. If you are having a good appearance, okay, it can be a stone, it can be a person or whatever, whoever it may be, the appearance is a very important factor. Okay, so the stones which are to be used for the face work should be decent in appearance. Suppose you are doing for some face work, that means the look, the forward look, that should be in the next is appearance. Appearance means, what is appearance? I am having a good appearance than you. What is that meaning? That is always, if it is a new person of whoever it may be you, it may be me, whatever it may be, the appearance plays a very good importance, a very good factor. Okay, if you are well dressed or your face is very good, very pleased, means your appearance is wonderful, means everybody will attract you. Like that only, we are categorizing your with a good character of a good building stone is appearance. The stones which are used for different work, it may be face work or whatever it may be, should be decent in appearance, and they should be capable of preserving their color uniformly for a long time. Okay, they should be capable of preserving their color uniformly for a long time. This is very important. The appearance is important. The appearance that you have to maintain, that should be maintained for a long time. Okay, it shouldn't get lightened or something. Okay, so the color, the appearance, that is very much important. Appearance in the sense the color, the beauty of the stone. The color of the sometimes the stone will not be plastered. Okay, the stone will be exposed directly by applying some varnish or something. You would have seen some in some architectural buildings. So it plays a very important role. Appearance or the color or whatever it may be. So the color of the stones for face work should be chosen. Face work means, that's what I told. Some architectural work they'll be using, they won't be plastering. They'll be exposed directly to the atmosphere. So what we are facing is the stones itself, not the wall, means plastered wall. Okay, that sort of things and all. Color is an important factor. It is desirable to prefer light colored stones. This is very important. Light colored stones are preferred compared to dark colored stone. This you have to keep it in mind, because there are chances of latter variety to be attacked easily by weathering agents. Latter variety means that dark colored stones, there is a chance of weathering agent attack. Okay, some portion may be weathered away by some wind or some water, whatever it may be. There may be a chance of that. So better use light colored stones. That's what it tells. A good building stone should be uniform color and free from clay hole, spots of other color, etc. There won't be any clay holes. Okay, clay holes will be less compressive. Okay, not less compressive, they will be having higher compressive, less compressive strength. So avoid clay holes, avoid any spots of other color. Okay, should have to any spots or any holes, avoid all those things. You know, clay is having less strength, so avoid all those points. Okay, durability. A good building stone should be durable. The various factors contributing to durability of a stone are its chemical composition, its texture, resistant to atmospheric and other influences, location, structure, etc. What is a texture? A texture is nothing but the arrangement of minerals forming a rock is known as its texture. Okay, what will be the arrangement of its minerals? A rock includes various minerals. What will be the arrangement? There will be lots of arrangement: compact crystalline arrangement, conglomerate arrangement, foliated arrangement. All those things you no need to study all those things. Okay, but it contributes the durability, chemical composition, the texture, the resistance to all the gases and all those things, location in structure and all those points you have to memorize. Then following are the important atmospheric agencies which affect the durability of a stone. What are the atmospheric agencies? Means atmospheric agencies. Alternate conditions of wetness and dryness due to rain and sunshine. There may be sometimes rain. Okay, sometimes the sun may shine. What will happen? Alternative wetting and drying may take place. That may affect the durability. Durability means the longevity, or how much years it will last for its full strength. That's what durable means. Okay. Chemical agencies such as dissolved gases in rain, that may some chemical reaction between the gases in rain with the stone, minerals in stone may occur. That may degrade the rock. The growth of trees and creepers in the joints between stones. In between the joints, there may be some creepers and trees may be grown. That may affect. Okay. Wind with high velocity. High velocity wind may weather. Sometimes the weathering may take place. That are all the points, atmospheric agencies, which affect the durability of the stone. For making stone durable, their natural bed should be carefully noted. What is a natural bed? What is a natural bed? The building stone actually are obtained from rocks that you know already. These rocks have a distinct plane of division along which stone can be easily split. There will be a plane of division. Only suppose you assume a stratified rocks. As you know, a stratified rock will be of, there will be of so many stratum. Okay, most probably this is shown in sedimentary rocks. Actually, this is the elevation view what we are seeing. In this elevation view, we can see so many horizontal planes. Actually, this is called the natural bed. In the lower bed, above the lower bed, there will be some sediments may be deposited. Above that again some sediments. Actually, these are the above the natural beds only this deposition taken place. Okay. So while you are constructing a building or whatever it may be by using some stone means the natural bed should be perpendicular to the plane of pressure. If this is the plane of pressure means the natural bed should be like this. Okay, natural bed should lie like this. Plane of pressure should be in this direction. Okay, so what will be the angle between this plane of pressure and natural bed? This is the natural bed. I have shown you two natural beds. This angle will be 90 degree. That's what the natural bed is perpendicular to the direction of pressure. The weight of the stone will be in vertical direction. Natural bed should be in this horizontal direction. So the angle between them is 90 degree. So these are the various parameters that you have to take in account when you are doing the durability designs. Okay, you should consider the durability factors. What are all the factors? So durability is an important characteristic of a good building stone. Okay. Facility of dressing. The stone should be such that they can be easily carved. Carved means the different shapes will be produced by carving it. Stone carving. You would have known about this. Molded, cut, and dressed. Okay. The stones should be such that they can be easily carved. Should be easily carved. Okay. Facility of dressing. Molded, cut, and dressed. It has to be. It should be such that it can be easily carved, molded, and cut and dressed. It's an important concern from the economic point of view. Okay, there should be facility of dressing at the quarry itself. If it is not there, definitely it has to be done at the site. Okay, നമ്മുടെ നാട്ടിൽ കല്ല് ചെത്തൽ എന്ന് പറയും. കല്ല് ചെത്തൽ ഒന്നുകിൽ ക്വാറിയിൽ നിന്ന് ചെയ്യണം, അല്ലെങ്കിൽ എവിടെ നിന്ന് ചെയ്യണം, നമ്മുടെ വീട്ടിൽ കൊണ്ടുവന്നിട്ട് ചെയ്യേണ്ടി വരും നിങ്ങൾ. അതായിരിക്കും നല്ലത്. Hence, it is to be properly correlated with respect to the situation in which stone is to be used. ഏത് സിറ്റുവേഷനിലാണ്, which situation what we are using, whether we are using for an architectural purpose, whether we are using for that sort of situations you have to consider. So, facility of dressing may depends the characteristic of good building stone. Okay, the facility of dressing in the sense കല്ല് ചെത്തുക, അതിന്റെ ഇംഗ്ലീഷ് ആണ് facility of dressing. Okay, കല്ല് ചെത്തൽ characteristic of building stone affect ചെയ്യുന്ന സംഭവമാണ്. Okay. Then fracture. For a good building stone, its fracture should be sharp, even, bright, and clear with grains well cemented together. Fracture. Its fracture. Okay. Consider a stone. This is the fracture area. In this way only it may. If we hammer it here means the cutting plane should be in this direction. This is called a fracture. The fracture should be sharp. It should be even. Should be bright and clear with the grains well cemented together. Okay, there will be so many fractures. Okay, in some plane that should be very sharp and even, bright and clear. Okay, always that is the weakest plane, but they will be cemented together. Okay, there won't be any breakage. See, if it is there means definitely that may affect the quality. Okay, a dull, chalky, and earthy fracture of stone indicates signs of early future decay. Take a stone, just observe it. If there any dull fracture is there, try. If there is any dull fracture is there, just strike it and see. A dull, chalky, and earthy fracture means that won't be a good stone. If it is a good stone means sharp, even, bright, and clear fracture will be there. They will be cemented. They will not be broken. Broken means we cannot use it. Okay. So that are the points. Next, hardness. Hardness is another parameter. Hardness means, as you all know, what's hard. Hard means what? If a body is hard, if your mind is very hard, somebody will be telling his mind he's very hard in character, like that you'll be telling. Okay, there will be a test called hardness test. In the laboratory, we are conducting Dory aberration test. In our laboratory, Dory aberration equipment is not there, I think. In this, In order to check, after this we'll discuss, we'll come to these points. Okay, first we'll tell how this experiment is conducted. Take stone, any kilogram you can take some kilogram of stones. Okay, then apply, then put it, you have to apply 1250 gram load on that. What will happen? It will become like some dusty particles, some small, it will convert it into small particles. Just take that and pour it here. Here one point is there, just pour it here. Take that stone and pour it here. Okay, actually this is a rotating cylinder. This thing is a rotating cylinder. Okay, then what will happen is you have to rotate this, which is connected to some plug point. Switch on that thing, then this thing start rotates. Where we have poured the stone, here only we have poured the stone. It is there inside this, some small nadam like thing. Okay, then what will happen at the time of rotating? Just try to ooze out or try to open this thing. So what will happen? The stone particle may fall in this above this rotating cylinder. Okay, above this rotating cylinder, above this rotating cylinder. After 28 radians per minute, you have to rotate it. That is also 1000 revolution. That also will be displayed in this meter. There will be a meter in this. So what you have to observe? Just take initial weight. Initially you would have taken some weight, initial weight. Okay, initial weight will be there. Just take the final weight. After you are falling this, you are putting the materials above this rotating cylinder. Some of the material may be weared off, or some may be converted into dust and all. Some of the material will be lost. Just take the material, okay, from what remaining material is taken off. Then you have to subtract from the final material. Okay, initial minus final means you will get what will be the loss in weight. You will get the loss in weight. Please remember, this is a rotating cylinder. Some amount of dust or some amount of rock will be gone. Okay, so initial minus final means we will get the loss in weight. Loss in weight. 20 minus loss in weight in gram divided by 3. You have to do this. Then you will get some value. That is called the coefficient of hardness. This is how Dory aberration test is conducted. Nowadays we are using the Los Angeles aberration test. We are not at all doing, but in conducting the hardness test of stone, Dory aberration test is recommended. Okay, so the coefficient of hardness as worked out in hardness test, you no need to study all these procedures and all. You study this, all those things, memorize all those points. As worked out in hardness, you should not be greater than 17 for a stone to be used in road work. It's between 14 and 17, the stone is said to be in medium hardness. If it is less than 40, the stone is said to be poor hardness, and such stone should not be used for road work. All those points you have to memorize. Okay. Next, characteristics of good building stone. Okay. In characteristics of good building stone, next we will discuss about percentage wear. In percentage wear, we will be using the attrition or aberration test equipment. That is the Devil attrition machine. You would have heard about this. This is a very, in our laboratory, this machine is not present. Okay. So actually, what is wear and tear? If it is a machine also, some amount of wear occurs. Okay. So okay, some amount of wear may happen. So to determine the rate of wear of stones, okay, how we'll do that? Take 50 Newton sample. If you are converting to kilogram, just divide by 9.8. 50 by 9.8 kilogram sample is taken. Then there will be a cylinder here, which is having a dia of 200 mm and length 340 meter. Just put the sample in these two cylinders. Then rotate at 30 rpm for 5 hours. Okay. Initially some 50 Newton sample is taken. Then you have to rotate it for 5 hours. After 5 hours, you measure the final weight. Okay, what is remaining inside the cylinder. Okay, just initial, as we have done in Dory aberration test, initial minus final, you will get the loss in weight. Initial minus final, you will get the loss in weight. Loss in weight divided by the initial, you will be getting the percentage wear. Loss in weight divided by initial, you will be getting the percentage wear. ഒന്നുമില്ല, ഈ സിലിണ്ടറിൽ ഇട്ടിട്ട് കറക്കിയിട്ട് അപ്പോൾ കുറച്ച് മെറ്റീരിയൽസ് എന്ത് ചെയ്യും, ലോസ് ആവും. സം amount of wear loss will happen. So initial weight ഞാൻ പറഞ്ഞിട്ട് 50 ന്യൂട്ടൺ എടുക്കണം. അപ്പോൾ അതിൽ നിന്ന് മൈനസ് ചെയ്ത് എന്ത് കിട്ടും, ഫൈനൽ വെയിറ്റ് you will get. ഓക്കെ, ഫൈനൽ വെയിറ്റ് നിന്ന് ഇനീഷ്യൽ കുറച്ചാൽ ലോസ് ഇൻ ഗ്രാം കിട്ടും. ലോസ് ഇൻ ഗ്രാം ബൈ ഇനീഷ്യൽ വെയിറ്റ് എടുത്താൽ നമുക്ക് അത്രയാണ് അതിന്റെ അബ്രേഷൻ വാല്യൂ അല്ലെങ്കിൽ wear and tear വാല്യൂ എന്നുണ്ട്. ദാറ്റ് ഈസ് 3%. If wear is more than 3%, the stone is not satisfactory. If it is equal to 3%, it is satisfactory. Okay. For a good building stone, that is the wear should be equal to or less than 3%. നല്ലൊരു സ്റ്റോൺ ആണെങ്കിൽ 3%-നെ കാട്ടി 3% ആവണം, അല്ലെങ്കിൽ 3% കുറവായിരിക്കണം. ഈ കാര്യം പഠിക്കാനുള്ളത്. Next, resistant to fire. As we know, what building we are constructing, it should be resistant to fire. Okay, the mineral composing of, if our building should be resistant to fire means, has to be resistant to fire means the building materials what we are using has to be resistant to fire. What are the building materials what we are using? What is the main constant? Stone is the main constant. Okay, so the stone, that is mineral composing stone, should be such that shape of the stone is preserved when fire occurs. If a fire happens, the shape of the stone should not be affected. The failure of stone in case of a fire is due to various reasons such as rapid rise in temperature, sudden cooling, okay, different coefficient and linear expansion of minerals. Stone is a chemical thing, so there will be some how the chemistry behind how stone is formed and all those things. So due to the different coefficient of thermal expansion, there will be expansion and contraction between the different means the constants of the stones. So what will happen? So it may affect the structure of the stone. So sometimes it can break. Whatever the stone, there may be granite, there may be simple stones will be there. There may be lots of stones are present in our present day buildings. The free quartz suddenly expands at a temperature lower than 600. That's an important. If quartz is used, it will suddenly expands at a temperature lower than 600. Limestone resists fire up to 800 degrees Celsius and it then split into CaO. Up to 800 degrees Celsius, limestone can resist fire. These are all the points that you have to keep it in mind. When you become a good engineer, you have to apply all those things. Sandstone with the silicates as binding material can resist a fire in a better way. Sandstone is a good material. The argillaceous stones are poor in strength, but they can resist fire quite well. What about the argillaceous stone? He wants steady, but he can do some other thing. Like that, argillaceous stones are poor in strength, but he can resist quite well. Okay, fire quite well. So it's a fire resistant material. Argillaceous stones are fire resistant materials. That is the point that you have to remind. Under seasoning, the stone should be well seasoned before put into use. First of all, we have to know what is seasoning. Seasoning is a process which removes the moisture content of stone. There will be some moisture in the form of quarry sap, which is known as quarry sap. The presence of this moisture makes the stone soft. It makes the stone soft. So what we have to do? We have to dry the stone for a period of 6 to 12 months. This is what recommends. Okay. So hence, since the moisture makes the stone soft, the stone quarried freshly are easy to work. That is a very important point. Since it is a very soft, they are very easy to work. Okay, so it is therefore desirable to do dressing, carving, etc. So as soon as fresh stones are obtained from quarry, it is very easy to do dressing and carving and etc. If you want to do some architectural working, you can do for carving. Okay, that is, it contains some quarry sap. Quarry sap means some moisture. Okay, if it dries out about 6 to 12 months means it will become more hard. So that will be good for use in construction works. If you want some strict retaining wall work or some normal wall work means you should want some rigid stone. Okay, for that purpose and all you can go for 6 to 12 months seasoning period so that moisture may dried off. Okay, specific gravity. Specific gravity is actually a relative density. Okay, how much times it is having denser than water. What is the specific gravity of water? Which is 1. What is for a good building stone? What is the standard? 2.7. That means it is having 2 into 2.7. 1 into 2.7, which is having 2.7 times specific gravity than water. Okay. If a stone is dipped in water, stone stands below and water stands above. That is the specific gravity means. So if you are using heavy stones means we will be having heavy specific gravity. If the lighter stone variety will be having less specific gravity. All those things. That is a good characteristics of building stone. So you have to memorize all those points. Which one will be having the specific gravity. Andesite is having 2.22. Basalt is having 2.77. Okay, limestone is having this much. There may be some questions for public service examinations from this part. What will be the specific gravity of igneous rocks and all those things. Okay. Characteristics of good building stone. Next is texture. A good building stone should have compact, fine crystalline structure free from cavities, cracks or patches of soft or texture is a very important. See how the texture, they are very much close. See, fine, crystalline, free from any cavity. They won't be having any cavities. They are like small crystals. Okay, cracks or patches. A good building stone will be like that. The stone with such a texture are strong and durable. It's more lasting. It lasts almost around 30 or 40 years. That's what. A good texture is a very good indication of good building stone. Next, toughness index. We will be conducting impact test for determining the toughness index of a material. Here we have to know what will be the toughness index of the stone. Just take some amount of stones in this cylinder. This cylinder is having a diameter of 25 mm and height of 25 mm. Okay, there will be height of 25 mm and dia of 25 mm. If then what you have to do is that there will be a steel hammer. This is the hammer actually, which is having 20 Newton weight. Okay, 20 Newton weight. What you have to do is like you have to drop this hammer by holding here from 1 centimeter height, from this point, from 2 centimeter height this point, 3 centimeter, 4 centimeter, like that. First you have to drop in 1 centimeter, then second 2 centimeter, then 3 centimeter, 4 centimeter, till the failure of that rocks, till it becomes dust. Okay, or the stone is become not tough. Okay, so like that you have to do it. You have to do this procedure. From some 1 centimeter I drop above this, then go for 2 centimeter, then for 3 centimeter, for like that. If you are going till, if it is 19, if you are going 19 means the stone is high tough in character. Okay, it becomes 13 to 9, it fails or it becomes some dust in 13 to 19 means it's moderately okay. If it is not at all tough means from the 13th drop it will become dust. So what will be the, if it exceeds 19, 20, 21, 25 centimeter drop times and 25 centimeter drop also, if it is not becomes dust means it is highly tough. We can we can conclude that it is highly tough in character. Okay. Next is water absorption. Water absorption. All the stones are more or less porous, but for a good stone, percentage absorption by weight after 24 hours should not exceed 0.60. Okay, that is after 24 hours. If you are taking the stone, okay, put it in the water yesterday and you are testing today. Okay, means after 24 hours, the percentage absorption by weight should not exceed 0.60. How to test this? Just find out the water content weight of that stone today. Just find out, just take the initial weight by yesterday, just minus it, then divide it by the initial weight. You will get the percentage 0.60. Okay, only it should not be like, it should not exceed 0.60. That is the limit. The porous stones seriously affect the durability of stone. It should not be porous. If it is greater than 0.60 means it becomes more porous. The rainwater as it descends through the atmosphere absorbs some acidic gases forming light acids. So the rainwater should not be descend through it. Such rainwater, if absorbed by porous stones, react with the constant of stone, causing them crumble. Okay. So avoid the porosity, that is don't 0.60 greater than 0.60. So you will be having this much of consequences. There will be some chemical reaction. There will be some reaction with the gas forming light acids and all those things. Okay. So the next is weathering. A good building stone should possess better weathering qualities. Okay. If it is a good weathering stone, means it is weathering resistant. It may be resistant to weathering. As we have already discussed about that, what is weathering, what are the weathering agencies. So it will be easier to understand all this. The best way to know the resistant power of a stone is to the action of weather is to study the performance of building constructed with the similar stones in the locality or at place having more or less similar atmospheric condition. See, just you go and see your neighbors. If you are going to construct a building at the Tottenham, just go and check how our stone is behaving at what in Kannur Government Polytechnic. Just go and take a visit on that. The stones having excellent weathering qualities should only be used in construction. Okay, that you have to keep it in mind. It should, however, be remembered that one kind of stone is not suitable for all type of that is we know. Okay, we are using different stones. Granite stones we are using for flooring. Then if you are for wall means we are using the natural stones. For instance, the soft stones are required for carving. The light stones are required for arches, and hard stones are necessary to stand high pressures. Okay. The soft stones are required for carving. For carving, we are using the soft stones. For the light stones, we are using for high pressures. Okay. Sorry, light stones are required for arches, and hard stones are required to stand high pressure. Like in order to build a wall, we'll be using the hard stones. For if you are doing some carving or some architectural work, means you'll be using the soft stones. So that's it. The characteristics of good building stones. We have discussed the 14 points. Go through all the points, study them thoroughly. If you are having any doubt, you can query through the Google Classroom. Thank you.